Good morning, everyone. In this session, I'm going to explain about the implementation of logistic regression. We already discussed what is logistic regression. It is a classification algorithm. It is going to classify the data into any discrete data into two labels. So now here, I'm going to explain how we are going to implement this logistic regression with the help of one data set. That data set here, you can see here, the link I have provided here. From Kaggle, you can download this data set, that is social network ads. So what is this data set is? There is some list of data is there where a particular user ID, gender, and his age and estimated salaries are the four columns. And one discrete label is whether as per the age and the estimated salary, whether he is going to buy a new product or not. That is what this data set is. So here, uh, already I discussed two programs regarding this data pre-processing and linear regression. Now it is logistic regression. The same showing this implementation in Google Colab. The very first step, you know that we are going to import the libraries, that is NumPy, Matplotlib, and Pandas. Then the next step is this is where we are going to acquire the data set, and this where we are going to upload our data set. For that, what you have to do is from this particular website, first download your data set. Then there is another way to upload the data set in Google Colab. In week 3 program, I told how to upload the data set one way. This is the other way how we are going to upload the data set in Google Colab. So here from google.colab import files and uploaded equal to files.upload. So once you run this program, here you will get an option for choosing the files. So from here, you choose the file where you have downloaded the data set and you just upload the data set into there. Then create a one variable of this to upload this data set into our particular program. Just I have created a one variable df. I'm just reading the CSV file. That is, this is the data set name. I have changed the data set name into sub_data.csv. Then the next step is I'm exploring the data set, that is df, where our data set is there, df dot head. You know, this dot head describes the first 5 rows of the data set, and this df dot describe. You want to know more about data set, then we are going to use this one. Okay, so these two, just to see the data set what it consists of, just use these two functions, df.head and df.describe. Then next one, just checking for null entries. Is there any null values in the data set or not? For logistic regression or any implementation of any regression, there should not be no null values. You have to make sure that there is no null values in the data set. And in data pre-processing, we have seen how we are going to fill the null values also, if any. So that is df.isNull.values and it is sum. So after checking this, I found that there are no null values in this particular data set. Okay. Then the next two comes extracting the independent and dependent variables. Okay. So see here, in this is in independent variable, this is dependent variable. We know that the last column always indicates the dependent variable, and here independent variables we have taken 2 and 3, second column and third column. Why? Because age and salary, based on the age and salary only, we are predicting whether that particular person is going to buy a product or not. Not only product, whether any car or any thing he's going to purchase or not. So independent variables, I have taken it as 2 and 3, that is age and the salary. And this dependent variable is in the fourth column. Like that, I have extracted independent variables and the dependent variables. Now, our next step comes, you know that we are going to split the data set into training and testing. For that, we know that from sklearn.model_selection, we are going to import train test split. And we are going to create the 4 variable train test, ytrain, ytest. And you know that the function train test split, x and y, these 2 variables, test size is 0.25. That is 25% of the data we are taking for testing. and then random state equal to 0. 0 or 1, you can take anything for randomly selecting for the training data. Then the next step comes here, feature scaling. When I have seen the data set, I found there is lot of variations are there in the range of the values. So here I'm performing feature scaling only for the independent variables. Why we are not doing for dependent variables? Depend as this is a classification problem, dependent variables will have only zeros and ones. So we need not to do any feature scaling. But for independent variables, I made a feature scaling. For that, we know from sklearn dot pre-processing, this is pre-processing step. I have imported standard scalar and I have done standard scaling for training data and the testing data and fitting the training data and transforming that it into test data. Now it's time to build the model. Our model we are constructing this model for logistic regression. So from sklearn.linear underscore model, everything we are going to download from sklearn. We are going to import the logistic regression. Okay, so just simply import logistic regression from sklearn.linear underscore model. Create an object, logistic regression and random state equal to 0. You can take any number. Okay. Then this particular object, I am fitting training data of X training data and Y training. X indicates independent variables, Y indicates a dependent variable. And then now predicting the test set result. Now I want to predict the test results. Okay, training I have done. Now I want to predict the results for the test data. For that, again, you create one object, that is classifier dot predict. Classifier is from here. Predict is the function which we are going to predict the data, and X test is the variable coming from here. This one from training set. Then yes, we have predicted the test results. Now I want to display the results. For that, we are going to create a confusion matrix. I hope after you people listened to confusion matrix, you know how we are going to build a confusion matrix and how much important a confusion matrix is for classification problem. For that, from sklearn.metrics, these are evaluation metrics for classification problem. Just I am importing confusion matrix and accuracy score. I want to find out what is the accuracy and I want to show you the confusion matrix where I want to find the true positive, true negative, false negative. From that only we are going to find out the accuracy. Then just so confusion matrix, I have created one object. This confusion matrix here of what confusion matrix for what test data, that is Y test and the Y predicted. So we are going to construct the confusion matrix for test data and the predicted data. The same thing over I have written here. Then simply say confusion matrix. And I have created one more object and I want to find out the accuracy score. Again, this accuracy score is for test data and the predicted data. Just I am printing the accuracy. So my overall accuracy of this particular data set is I got 85%. And this is the confusion matrix. This is true positives, true negatives, false positives and false negatives. Okay. Now I want to visualize this confusion matrix. So visualization, we visualize this confusion matrix with all the labels. Now for that, I'm going to use this import matplotlib.pyplot as PLT and I'm also importing cborn as SNS. Why? For visualization, compulsory a machine learning program requires this matplotlib from Python library, and to show the display the confusion matrix with the different colors, compulsory we require this cborn. Okay. So why? Because from this cborn only we are going to have one more visualization called as heat map. So just create an object. So this SNS, that is cborn heat map of what confusion matrix, what we have drawn here, this confusion matrix. And annotation, these are the two things, two variables it requires. Annotation equal to true means it is going to display the values. C map is blue. BUPU is one of the color of this particular confusion matrix. Then We have to set a title for confusion matrix. That is confusion matrix for purchasing prediction based on estimated salary. This is our title of a confusion matrix. Then we have to set the X label, Y label. Okay. Then we also should have, this is just label of this actual status of this. These are the things. Okay. X axis, what is the name? Y axis, what is the name? For that, I will label this. Then for every confusion matrix, you just remember the theory part, what we have remembered. We are going to give here 0, 1, 0, 1. So here instead of 0, 1 and 0, 1, I am just placing it as purchased, not purchased. So to display these purchased and not purchased in a particular confusion matrix, we are going to use set underscore ticket labels. Okay? So that is AX in x-axis dot set underscore tick labels. One you write not purchased, purchased, not purchased, purchased. And even similarly y-axis set tick labels not purchased, purchased. And plt dot show this plot, this one, it is going to display the confusion matrix. So you can see this confusion matrix. So this is the confusion matrix what we have built. So means to visualize this confusion matrix in this much graphical representation, if you want to represent, then compulsory we have to make use of all these libraries from Python. That is matplotlib, cborn, and from cborn we are going to use heat map. We have to set X label, Y label, tick labels of X axis and set tick labels of Y axis. Then only you can display a visualization of confusion matrix in this way. Now it shows that these are the true positives, these are the false true negatives, this is false positive, and this is the false negative. Okay, so this is how we are going to display the confusion matrix. But this is how we are going to evaluate the classification algorithm. Now, as this logistic regression is a classification algorithm, we have evaluated this logistic regression with the help of this confusion matrix, and we got 85%, which is a good accuracy. And we have very less false positives and false negatives. So we can say that our model is the best model. Thank you.